Domain range of looks like a linear function. Yeah, the model's a real-world situation. So we got the owners of a recreation area. They're filling a small pond with water, and they give us an equation for W, which is the amount of water in the pond, and T is the total amount of minutes that the water has been added. So obviously W should go up as T goes up, right? The longer you wait, the more water that should be in it, assuming that we're still filling the pond. So they give us an equation about W and T. And then during the next 90 minutes. So we just have to remember that W, and this is important because it's talking about domain range here. They say that W is a function of T during the next 90 minutes, okay? So that means that T needs to be somewhere between 0 and 90 minutes because you can't have negative minutes of pumping water, right? T has to be between 0 and 90 minutes. So since T is the input variable, it's the thing that determines what W is. It's not the other way around. The time, the amount of water. We're not using the formula. The way it's set up is that you plug in T and it spits out W. Okay, so T is our domain variable, and so that's got to be from 0 to 90. Okay, I didn't pick this one because T is supposed to be, we just said off to the side, they said it goes up to 90 minutes. So it can't be this one because that's way over 90. That involves numbers over 90. This one's good. These are all involving times that are over 90 minutes. Okay, and like we said, the domain is the number of minutes the water's been added. Okay, and the range variable is the one, like when we usually write function notation, you say f of x equals blah, 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 right? This is the range variable. So if you look at this equation, it kind of looks like f of x, except it's just w, okay? So the variable that the equation's solved for, that's your range variable. So w is the amount of water in the pond. And then the set of values that w could be. So it's a linear function. So one thing you could do is you could go to like a website like Desmos and graph it, and then the y values are the values that are the range, okay? Let's do it without Desmos here. The y values are, the range, the set of values for the range are all the y values, all the numbers that could possibly come out. So the smallest amount is when we start at 0 minutes, right? When t equals 0, w equals, if you could do this with mental math, 25 times 0 makes 0. 0 plus 300 is 300. So that's the smallest amount of water in the pond. And then the largest amount is when we've pumped the maximum amount of time. So calculator for this one, when t equals 90, 90 times 25 gives us 2,250 plus another 300. That gives us 2,550. Oops. Okay, so our range is all the numbers between 300 and that's a bad 2, but 2,550. That's the one we want, okay? This one's going to be the same type of thing. Got to read the problem and think about all the different values, okay? The domain of this one, look, is S, and the range of this one is C.